Hello and welcome to this new video, the walkthrough of the vulnerable VM Toppo. I didn't plan to post another one for a few days, but I had the day off work, bank holiday Monday over in Europe, and this vulnerable VM is actually quite straightforward and simple, so we'll go ahead and have a look at this now. Okay, so let's get started. I've got my VirtualBox running on my Mac, and I've got my vulnerable VM Toppo running as well as my attacking machine, Kali Linux. So let's have a quick look at our vulnerable VM. It should be running there. You can see it's already telling us the IP address there, so we're not going to have to do any kind of ping sweep to find out what that is. So we've got 214, so that's a good start. And let's go ahead and get our Kali Linux machine over and full screen that. So again, these could be using the NAT for networking, or host-only adapter, or even bridged adapter if you need to give your Kali machine access to the internet. As long as they can actually speak to each other and they can communicate on the same subnet. Okay, so now we've logged in. We know what the address is of our vulnerable VM, so let's just double check the address of our attacking machine, which is 213. So the first thing we're going to go ahead and do is do a quick Nmap port scan to see what services are actually running on this vulnerable system. So here's the scan that I typically tend to use. Everyone's options they like to use for this scan will vary a little bit. This won't be a fairly quick scan, but it will scan all of the ports on the system, all 65,000 odd. It'll be a very verbose output. It won't conduct any kind of host discovery, and it will try and do a bit of detection of the operating system running as well. So I'm going to go ahead and just make sure the IP is correct for that, 214, and fire that off. So we've already got information on 4 different ports which are open. So the first one, 22, quite likely are SSH running on that port. 80, so there's probably some kind of web service running. And then we also have port 111 and port 52. Scroll back up a little bit, 52551. I believe from memory that port 111 was something to do with RPC bind, but again we'll dig into that port a little bit later should we need to. Right, okay, so next let's just have a double check to see if that SSH service is actually responding on port 22 as we would expect. Yep, so it's prompting us for a password. Obviously we don't know that password, so that's as far as we're going to get, but we do know that SSH is there and available. Maybe we can come back to that later. So next let's open up our web browser and have a look at that port 80 and see what's going on port 80. So I'm just going to pop in the IP address there. Oh, if I actually spell the IP address right, that would be useful. There we go, so we've got some kind of blog page showing up there. We've got a few different posts which we can click into in each one. Got a menu area, let's have a look about. Not much information about exactly what this is at the moment. Maybe it's just a simple Apache web server with some basic web pages running there. So let's start having a bit of a poke around at this and see what we can find. So while I'm going to have a poke around and see what I can find, I'm just going to kick off Durbuster in the background to do a crawl of the possible directories. So it's just using a list of possible directories there called common.txt, which is available on the Kali system. There you go, it's going to start hammering through those. And straight away I can see that it actually has an admin directory. And that first hit there. So that's quite interesting to me. I'm going to have a quick look first before I check that out to see if there's any robots.txt file as well. Okay, nothing there. Let's have a look at the admin directory which we saw pop up in that scanner. Okay, so we've got a directory and we've got a notes file. Also a little bit of information about the exact version of this Apache service which is running. Again, something we could note down to see if we want to look for potential vulnerabilities against that version. Let's have a look at this notes file. Note to myself, I need to change my password. It's too outdated, but technology isn't my thing. I prefer to go fishing or watching soccer. Must have been an American who made this. Okay, so we do have a potential password, so that is definitely going to be useful to me. So I'm going to note that down for later. So let's put that into LeafPad. Okay, that directory scanner is still running. So in the meantime, what I'm going to do is I'm actually just trying to start poking at that SSH area now using this password that we've already learned. See if I can have any luck with this. So let's do point at that web service, the SSH service. Sorry, paste in our password. And permission denied. I'm just going to double check that I got that right. So it doesn't appear to be the password for root. So we need to kind of find some different user accounts maybe to help us here. Just by looking at that password though, it does kind of look to me that the user might actually be called Ted. If it's a simple system, this might be a bit of a clue as to possible user account. So let's go ahead and actually try logging into SSH as Ted. So, prompted for a password, which is a good sign. And now we actually have SSH access as a valid user to that system. So that's really good news. We've managed to get in with that password that we found. So let's have a quick look. We are the user Ted. See a bit of information about who we are there. Let's see whether we can query the rest of the users on the system by looking at the password file in etc. And we can. I'm just going to go ahead and full screen that. Okay, so you can see our root user at the top there, mail, SSH, the www data, and Ted right at the bottom there as well. Okay, so let's see whether the permissions are properly set up on this system, and if they're not, we might have a bit of joy reading the shadow file as well to see if there's any password hashes for these users that we can crack. Permission denied. So it's not fully open. Let's have a look at what we can do next. So the next thing I'd like to do is maybe copy up some files to see what possible exploits we've got available to us based on what type of kernel is running, based on the operating system, based on the services and applications running. So first of all, let's see how I can move files up. So is there wget on the system? There is. Okay, so that's a possible method for us to move files up. So if I just open up my web directory on my attacking machine now, these are a few of the scripts I like to use for finding out what potential exploits we could use on Linux-based systems. So there's 4 there. There's linenum.sh, there's Linux Exploit Suggester, Unix Privesc Check, and Linux Priv Checker. Each will give you slightly different results, but some might give you a nice clue in which direction to go next. So I did actually run all 4 of these the first time round just to have a browse of the type of results they were bringing back. But in our case, we're just going to pick out the one which is going to send us in the right direction, which is going to be this Python version of the script. So first of all, let's just make sure that our web service is actually running on our attacking machine, so those files can be picked up. Great. Now let's go ahead and actually pick that script up. Linux priv checker.py. Seems to be taking a bit of time there. I might go ahead and just stop the dirbuster. I can always go back and rerun that if I want. Just a little bit concerned it might be interrupting me grabbing this file. And I'm also just going to double check the permissions on that file where it sits. Yep, so it's got open permissions. Let's try www.get. Just double check that we've got the IP address right again of our attacking machine. Yep, 213. There you go. So there's a slight typo in the IP, which was why it was not working. There you go, great. So that's actually worked now. Just check where we're sat. We're sat in Ted's home directory. And we've got our Linux Priv Checker 1 there, and a few other files I was working with before. So let's go ahead and just clear that. And I'm going to move that Linux Priv Checker 1 to the temp directory, and I'm going to call it lin.py. And I'm going to open up the permissions on that. Okay, so that's now ready to run. So let's go ahead and run that. We will run it just using Python. We actually need Python to be on the system to be able to run Python scripts. So let's just double check that that actually is installed, which it is. So that's great. Let's go ahead and run that script now. I'm going to output it to a file called output.txt. I'll just take a moment to run. Yeah, so we've got a good chunk of data in that output.txt file now. So I'm going to now have a look at that. If I have any ability to type. Great, so there's going to be a great chunk of information here for us to pour through. So let's just have a quick browse through this information from the top. As it does pull out a great bit of info here. So there you've got the Linux version there. It's a version of Debian. And the IP address of the vulnerable system, the services running, the ports that are open. the scheduled jobs, enumerating the user information. So that's quite interesting. It looks like Ted, the user, which we are, is able to actually run Orc as a privileged user without using a password. So I'm definitely going to have a check about whether I can do anything with that. Again, it's got our password file info which we've already got. Interesting, it says current user root. It's also making a reference to the fact that we are root. Are you sure you're not root already? Huh. And it's also able to actually query the contents of the root directory. And we can see there's a world writable file. Python 2.7 is owned by root and executable by anyone. Interesting. Let's keep having a quick browse through these. Some weblogs. Look like Apache weblogs. Okay, so there we've got access to the shadow file. We're definitely operating as root here. So we've got the hashes out. So that's kind of weird. So we'd already tried to look at the shadow file. So we definitely can't browse into the root directory now. And we definitely can't look at the shadow file now. But we can when we run that script. So basically Python must be running as root. So in theory, all we should need to do now is to spawn a shell using Python. Should actually spawn this as root. Okay. And now we look like, let's do a quick who am I? We are actually root on the system. So we've gone from boot to root. Okay. Well, thank you very much for watching this much shorter video. I hope you enjoyed it, and I look forward to the next one on VulnHub VM.